Hi everyone. Today I want to discuss the concept linear convolution in digital signal processing. The linear convolution of two signals is represented as y of n equal to x of n convolution with h of n. So x of n and h of n are two given signals. Its convolution is represented like this. The formula for this one is k varies from minus infinite to plus infinite, x of k, h of n minus k. We can solve this convolution by using either direct formula or by using graphical method. This is by using formula method, and another one we have graphical method also. Okay, so if you want to go with the formula method, it is somewhat difficult. We can always prefer graphical method to solve the convolution. So let's see the formula method first, and then we'll see the graphical method. Let's take x of n is one signal, some 1 2 3 4, and h of n is another signal, some 1 2 1 2. The origin of the signal is represented with arrow mark. Wherever the arrow mark is mentioned, that particular sample is indicating origin sample. So y of n is equal to sigma k varies from, actually k is from minus infinite to plus infinite, but for finite duration sequence, this sequence contains 4 samples. This sequence is also contains some 4 samples. So let it be some n samples. If it is finite number of samples, we can take k value finite values only instead of taking infinite range. So what finite value we should take? Here it is, the signal is ranging from 0 to 0 1 2 3. So axis starting from origin 0 1 2 3. Okay, so 3 is the last sample, so we can take from minus 3 to plus 3. So it covers all the values. So this is one of the way we can restrict unwanted computations. So x of k into h of n minus k. So what is n range? So n range is L plus m minus 1. What is L means? Length of first sequence. The length of first sequence is 4. M is length of second sequence. It is also 4. So n is equal to L plus m minus 1. 4 plus 4 minus 1 is equal to 7. So we want to calculate y of n for 7 values, that is n ranging from 0 to 6. Okay, so we need to substitute n value from 0 to 6, and we want to vary the summation k from minus 3 to plus 3 for every value of n. So let's see, we'll calculate y of 0 up to y of 6. So when it is y of 0, just we'll substitute in the formula y of 0 equal to sigma k equal to minus infinite to plus infinite x of k into h of n minus, n is 0, right? 0 minus k. Just simply substituting n is 0 in this formula. So sigma x of k varies from minus 3 to plus 3. So x of minus 3 into h of minus 3 into minus of minus 3 is plus 3, plus x of minus 2 to 2 into h of 2, plus x of minus 1 into h of 1, plus x of 0 into h of 0, plus x of 1 into h of minus 1, plus x of 2 into h of minus 2, plus x of 3 into h of minus 3. So if you see here it is covering from x of 0 to x of 3 and also x of 0 to x of minus 3 also. Minus 3 to plus 3 it will cover both the sequences. So if you see in the sequence we have from 0 to x of n ranging from 0. So 1, 2, 3, 4 is the signal. In 1, 2, 3, 4 starting value is 0. X of 0 is 1. X of 1 is 2. X of 2 is 3. X of 3 is 4. So there is no x of minus 1, minus 2. So as x of negative sample is 0, this will be 0, this will be 0, this will be 0, and even h of n is also having no samples at negative n value. So this is also 0. Only we will get the value x of 0 into h of 0. So x of 0, 1, h of 0, 1. So value is 1. Similarly, you substitute y is n is equal to 1 in y of n. Then the formula will become k equal to minus 3 to plus 3 x of k into h of 1 minus k. Okay. Now you vary the k value from minus 3 to plus 3. X of minus 3 into h of minus 3 minus k minus 4. So plus h of x of minus 2 into h of minus 3. When you substitute minus 2, minus 1 minus of minus 2 is plus 3. So here 1 minus of minus 3 is plus 4. Okay. So similarly it will be x of minus 1 into h of 2 plus x of 0 into h of 1 plus x of 1 into h of 0 plus x of 2 into h of minus 1 plus x of 3 into h of minus 2. So just we will vary the k value here, and based on the sequence we will substitute here. So in 1 2 1 1 2 1 2 is the h of n. Okay. So this is h of 0, h of 1, h of 2, h of 3. Okay. So similarly it is x of 0, x of 1, x of 2, x of 3. Okay. So we'll substitute these values. So we'll get all the values will become 0. Only we'll get these two samples. X of 0 into h of 1. X of 0 is 1 and h of 1 is 2 plus x of 1 into h of 0 is 1. So it will be 4. So similarly we can find out the value for n 0 to 6. So this is one method to find out the linear convolution. The another method is easiest method is graphical method. In graphical method, so if they given a sequence 1 2 3 4 and another sequence h of n equal to 1 2 1 2, you represent these two sequence on a graph, but instead of n you represent as x of k. Okay, and h of k. So you represent sequence with a dummy variable k instead of n. So what is x of 0? X of 0 is 1. At 1 x of 1 is 2. At 2 x of 2 is 3. At 3 x of 3 is 4. Similarly for h of 0, at 0 h of 0 is 1. At 1 h of 1 is 2. At 2 the value is 1. At 3 the value is 2. What is the step we want to do is first step. So we know the formula y of n equal to, we know the formula y of n equal to sigma x of k h of h of n minus k. When n is equal to 0, first when n is equal to 0, what happens? X of k into h of 0 minus k. That means the first step, when n is equal to 0, we want to fold the h of k. That is, we want to represent h of minus k. Okay, minus k means h of k is folded version. Folded version means the positive samples will come to the negative side. Okay, so this is 3 2 1 2 1. Okay, at 0 minus 1 minus 2 minus 3 2 1 2 1. So now this 2 will be multiplied. This x of k and h of minus k will be multiplied. If you multiply, if you see here, there is no samples. Here all the values are zeros, but here the values are some values. This is multiplied with 0, will get 0 at this instant. Only the instant that is matching is here it is 1, here it is 1. So 1 into 1 is equal to 1. So this is y of 0. When n is equal to 0, we are finding this one. So next step is, when n is equal to 1 means we want to right shift the folded sequence. So this sequence will be right shifted. Then it will be like this: 1 2 1 2. This is at minus 1 minus 2 0 1. So this will be multiplied with x of k. So y of 1 is equal to, when n is equal to 1, right? So this is h of 1 minus k will represent as, when n is equal to 1, this is h of 1 minus k, right? H of 1 minus k. So you will multiply this with x of k. In x of k, at 0 it will start. So at 0 the value is 1 in x of k. H of 1 minus k, the value is 2. 1 into 2 plus, here the value is at 1, the value is 2 in x of k, into, in h of 1 minus k, at n is equal to 1, the value is 1, plus, for remaining values, this will be 0 in h of 1 minus k, but in x of k some values are there. This value multiplied by 0 will get 0. So this is 4. The same values we got from the previous method also. So this is very simple. So when n is equal to 2 means we will right shift this sequence. So we will right shift this sequence by one more time. So this values will be shifted by one more time. 0 1 2. So 1 2, this 1 will come at the origin, this 2 will come at minus 1. So now this is h of 2 minus k. So this will be multiplied with x of k. So y of 2 is equal to, so where these three samples are matching, here it is non-zero samples from 0 to 2, here 0 to 2. Remaining, this is 0 in this part is 0. So 1 into 1 plus 2 into 2 plus 3 into 1. So we'll get 1 plus 4 plus 3. So like this you can perform the remaining steps up to y of 6. Okay. So to cross check this result whether it is correct or not, we will use this tabular method, or for a short answer question we can use this one. So write one of the sequence on the top as a row and another sequence as a column in the left side of this table. Okay, so you multiply this with all the values on the top. 1 into 1 1, 1 into 2 2, 1 into 3 3, 1 into 4 4, 2 into 1 2, 2 into 2 4, 2 into 3 6, 2 into 4 8, 1 into this one we are multiplying with all the values 1 2 3 4, 2 4 6 8. Just we will separate diagonally like this. Okay, so then y of n equal to, so this is first value 1, you have to add these products, 2 plus 2 4, 1 plus 4 plus 3, 7 plus 1 8, 2 plus 2 4, 4 plus 10 14, 12 plus 50 plus 3 15, 10 8. So we have seen in the previous two method, first method we got y of 0 1, y of 1 4, y of 3 2 7, same three values, 8. These three values we got same. So if you continue, we'll get the same values. Okay, so this is about linear convolution. Sometimes, so we want to cautious about the range. So n range we are telling length is L plus m minus 1. Okay, so 0 to L plus m minus 1 we are telling. Okay, so whether we need to take 0 to L plus m minus 1 or negative value, what is the range we want to take? This total number of samples will be L plus m minus 1. Okay, so L is length of first sequence, m is length of second sequence, L plus m minus 1 will be the length of the convolution sequence. So if x of n is one sequence, let it be 1, 2, 3, 4. Okay, and h of n is another sequence 1, 2, 1, 2, same sequence I am taking, but I am taking origin differently. So at this point I am taking origin, here at this point I am taking origin. So here the length of y of n is same, L plus m minus 1, that is L is 4, L is equal to 4, that means number of samples in x of n is 4 and h of n is also 4. 4 plus 4 minus 1 is 7 samples. Okay, so that is the length. So 7 samples from where to where? So previously we have taken from n equal to 0 to 6, 7 samples means, because in that case both the sequences are starting from origin, but here in this case it is not starting with origin. Then what is the range? N value range, n range. So we need to consider the first point, first index. So this is origin, the left side will be negative index. This is it is starting at -1, but here it is starting at -1, -2. This is origin, -1, -2. So we have to add the first two starting points, -1 plus -2, 2, and similarly we want to add the ending point. So this is origin, -1, 1, 2. Ending point is 2 plus here it is origin, comma 1. Ending point is 1. So -3, 2 plus 3. Here also we will get 7 samples, but the range is -3 to +3. N we want to substitute from -3 to +3. Okay, so if you do so n we need to substitute from -3 to +3, sorry, and if you do the formula based method, we need to substitute n value. If you do the graphical method, then +3 means we will do right shift 3 times for every n value. When n is equal to 1, 1 time, n equal to 2, 2 times, n equal to 3 means 3 times. Similarly we want to do left shift also when it is -3. 3 times left shift also we want to do for h of n, h of -n. Okay, so you have to cautious about this one. So in the graphical method, let's see, this is h of x of n. What is the value in x of n? At origin the value is 2, at -1 the value is 1, at 1 the value is 3, 4. So it is not started from origin, it is started from -1. So 1, 2, 3, 4. So what is h of k? What is h of k? So 1, 2, 1, 2, but it is starting from -2. 1, 2, 1, 2. Okay, this is k, x of k, h of k. So what is the first step? We want to fold this sequence. When you fold this one, the samples will be reversed. Here it is 2. Okay, here it is origin value will be same, 2, 1. So this will become to right side, left side values came to right side, right side values. This is h of -k. So this will be multiplied with x of k. So to get y of 0. So y of 0 is 1 into 2, 2 plus 2 into 3 plus 4 into 1. So that is 4 plus 6, 10 plus 2, 12. we'll get y h of, this is y of 0. So next what we want to do, we want to right shift the sequence by 3 times up to +3. +3 means 1 2 3, 3 times we want to right shift. So that is y of 1, y of 2, y of 3. Okay, similarly -3 means we want to left shift this -1, -2, -3. So 3 times left shift. So that is from y to calculate y of -1, -2, -3. If we shift beyond that one, the product will not exist. So this will be moving away from the x of k sequences. If you move beyond 3 in the right side, this sequence will be moving beyond the x of k scope. So the product will become 0. So that's why we want to cautious about the range of n. Okay, that depends on the origin sample given in the sequence. Thank you.